Good evening again, and welcome to video number 2. This video is going to be discussing section 3.2 of chapter 3, the slope of a line. So let's start with objective number 1. Objective number 1 is find the slope of a line given 2 points on a line. So in the first slide you can see this gives you some vocabulary words, what a slope is. Slope determines steepness or shallowness of a line. It's defined as rise over run. On page 174 of the text, you do have the actual formula that we're going to be working with. The formula is y2 minus y1 all over x2 minus x1, which also equals change in y over change in x, which also equals rise over run. While the equation just says y2 minus y1 over x2 minus x1, it does not matter which order you subtract the y values and the x values in. All that matters is that you subtract them in the same order. And the y1, y2, x1, x2 comes from the coordinate points that you will receive when you have 2 points in a line and you're asked to find the slope between the 2 points. Okay, so make sure you're reviewing the notes that you received in class. As we are going over this, take time to pause the video to look at the notes, try the problems, come back and look at them with me. So we are now going to go over the examples. First example is on page 182 and it is question number 9. With number 9, I am given part of the equation already done for me. I have the points plugged in, and all I have to do is solve for the slope. So to do that, I just simplify. 6 minus 2 is 4, 5 minus 3 is 2, 4 divided by 2 is 2. We always tend to want to think of our slope as a fraction, so we're going to write this as 2 over 1. Or you can see in the notes, it just writes it as m equals 2, but 2 over 1 is another way you can write it. If that's how you saw it in high school, I accept either way. Okay, next one is number 11. Same thing is already set up for us, so I'm just going to rewrite it from the textbook. Okay, and now I'm going to simplify. Double negatives means plus plus. So really that means negative 4 plus 4, which is 0. Negative 3 plus 5 is 2. Whenever I have a 0 in my numerator, that simplifies to simply a slope of 0. Slope of 0 is a horizontal line, which we saw back in 3.1. When you have a horizontal line, that is a line parallel to the x-axis. Okay, our last one in this manner is number 13. I'm just going to rewrite the question. Okay, so up here, this is really keep, change, so it becomes negative 6 minus negative 0, which doesn't do anything, so we're just going to write that as negative 6 plus here becomes 0. So now I have a 0 in my denominator. That means that my slope is undefined. You cannot have 0 in your denominator. We did discuss that a while ago. So an undefined slope is characteristic of a line that's parallel to the y-axis. It's a vertical line, and vertical lines are equations as x equals a number. Okay, so recap, you can have a slope that's an actual number, a slope that's 0, and this again is a horizontal line. Or you can have a slope that is undefined, and that is a vertical line. That information is important. We will be referring to that again in the future, so remember that. Okay, objective number 2 now. Find the slope of a line, given an equation of a line. Okay, review the notes that are there. Talks about horizontal and vertical lines. You can find them on page 176. So let's find the slope only of the following 3 questions. So we're on page 183 of the text. And we're actually going to be using the formula. So number 35. Oh, I'm sorry, not using the formula. We used the formula for objective number 1. We're not going to be using the formula again. But you have other examples that you can try that are on page 184, where you're given 2 coordinate points, and you have to then plug them into the equation to find the slope. Okay, let's go on to objective 2. So I'm given an equation. So when you have an equation, and the notes do give you the information, again, look on page 176, you always want to rewrite your equation from standard form to y equals mx plus b form. And when you have y equals mx plus b form, here is your y coordinate. The m stands for your slope. That's the value of slope. And here your b, that's your y-intercept. Those are the 2 most important pieces that we need for graphing using the y equals mx plus b form. And we're going to use that in a later section. That's when we get to section 3.3 and 3.4. We'll be using the y equals mx plus b form a lot. So all of our equations now are going to be in standard form. We want to rewrite them into the y equals mx plus b form. And from that, we're simply going to identify what is the number in front of the x. Okay, so let's do the examples. And we're on page 184, number 47. I'm sorry, no, we're not doing that question. I'm skipping ahead. We're doing number 35. I apologize. Number 35. And we're on page 183. I went too far in the textbook. Page number 35. So I have x plus 2y equals 4. So I minus the x. 2y equals negative x plus 4. Divide by 2, divide by 2. We did this on one of the first days. Divide each term by 2, you get negative 1/2 x. 4 divided by 2 is 2. Intercept, slope. So my slope here is negative 1/2. And you can see that answer in the notes. Okay, number 39. That's on page 184. 6x plus 5y equals 30. Minus the 6x on both sides. 5y equals negative 6x plus 30. Divide each term by 5. Y equals negative 6/5 x plus 6. Slope, intercept. Slope equals negative 6/5. And that's the answer you see on your notes as well. Last one, number 43. Y equals 4x. Whenever you have something without an intercept, this is going through the origin, so really your intercept is 0. Here is your slope. It's already written in y equals mx plus b form for me. So my slope is simply 4, or 4 over 1. So that's objective number 2. I'm going to end this video here. My battery is actually dying. So this is video number 2A. Look for video number 2B to continue the remainder of chapter 3.2.